At the beginning of this course, we're going to look at actually how SQL injection works with code that we have previously written on this channel. So if you're curious where this code or this website that I will be referring to as our portfolio build is located, I'll go ahead and list that as the first link in the description. We actually make a website from start to finish that is going to have a server, a front end, and a database link to it. And then in that project, we go ahead and make it vulnerable to SQL injection. And I'm going to walk you through that code at the beginning of this video, so that way you can see the secure code as well as the vulnerable code. That is kind of why I'm going to be walking you through that. But if you want to know how SQL injection code in the backend looks and works and functions like in its whole with the API, the server, and the database, you can go ahead and walk through or just watch that portfolio build, and you're going to get to see me code out the entire thing and talk through what exactly is going on. So we're going to check out like a 4-minute bit of that video of me walking you through what vulnerable SQL injection code looks like. Then we're going to move over to a port swigger, and we're going to start working through several different labs of SQL injection. They're going to be super basic and very easy. And then at the end, we're going to check out SQLmap and how SQLmap works and why it is such a great tool, and then how to actually grab the payload from SQLmap and use it on your own and actually be able to exploit the server yourself with the payload that SQLmap gives back, as well as dumping the database and finding the tables and the users and the passwords and all of that good stuff as well. So let's go ahead and jump into it. Okay, so right here is the code for our SQL database. These queries right here are what is going to be sending our information to the database. So here is our portfolio build, and if we click on our SQL injection over here, we're brought to our SQL injection page. We can create a user right here, so we'll make a new user just like this. We can submit our new user, and we can check out our database, and we can refresh it, and we have our new user right here. So if we come back over to our code, let's look and see what's happening. So we're taking in our input from our HTML. It gets passed over through the API, which I'm not going to show you because that's not the point of the video. And we have our query right here. So this is actually a secure input right here for SQL. So this is, you're not able to inject into this because we're taking our user and our password and we're sending those in right here inside these little variables right here that are not going to be able to break our query statement. So if we come back over here and we create a user with all of the bad characters, so we'll just say bad, and we'll throw in some of the bad characters, and then we can actually just copy this and send it over here. And if we submit this and we come back to our database and refresh it, we have all of our bad characters inside of our username because it doesn't break our statement, and our server picks it up right here with no problems at all through the API. But on our vulnerable code right here, you can see we have these queries. So this rec.body.user is actually going to take the input that we put from this login, and it is going to put all of it right here in this statement and then send the statement. It doesn't just send over the variables. So if we come over here and we just add in a single quote, it will break for us our statement, and then we can inject into it. So I want to show you what this looks like. So if we come over here and we put in these bad characters and we submit this, we're getting this error, and it's actually going to tell us like right here is we got this error, but more importantly, we crashed our server over here. So we actually need to restart our server. And when you see this error message or we crash our server, this is what you see when you're looking for SQL injection and you're putting in that SQL quote everywhere, is to see if you can break this statement and the server will send back a response. So we crashed our server. So if we were on a live program, we would know that this server is vulnerable to SQL injection. And in the case of a login right here, if we wanted to log in, we can just say anything. So we can just say bad characters like we did before. We can put in our single quote, and now we can put in or 1 equals 1, and then we'll close this off with our semicolon, and then we want our hashtag to comment out everything after our statement. Our password doesn't really matter, so you can put anything in, and it's going to tell us that we are logged in. And just to show you that this does work without the SQL statement, if we go ahead and submit this, it's going to tell us that we have the wrong username because it doesn't exist. So we're actually able to bypass this login function because we have insecure code in our login function but we have this secure code for our create a user function. If we wanted to, we could actually write a statement that is very similar to this, where we pass in these variables right down here, and then our SQL injection would be fixed. So inside of a Node.js server, this is how you would write a SQL statement for secure code and insecure code, and it's going to look really similar no matter what the programming language is. And we can actually see over here our example of a database. This is this database server that I have linked up to the Node.js server. So now you have a really good visual of what's happening on the database server, what the database looks like, the code on the actual server running the web application, and then how it all works when you bring it all together inside of our portfolio build. At this point, we're going to be heading over to Portswigger, and if you want to just find the website really quickly, you can check the link in the description. And we're going to start with bypassing a login function. It's really simple and really easy, but it is something that you're going to run into, especially in the world of certifications and CTF. So let's go ahead and check this out. All right, there are a few more things I want to show you in bypassing a login function. So you can go ahead and open this up. I've opened it up over here, and when you read this, it tells you that we're going to log in as the administrator user, and I think this is too much help why this is the lowest level as apprentice. In the wild or in a CTF, you're not going to have this username, and you're going to need to figure it out on your own. So go ahead and open this lab, and I want to show you why I think you're going to need to try and figure things out on your own. When you're doing a CTF and we come over here and we say we want to log in, or maybe you're really testing a login function, and you come to the name and we put in a name here, and then we intercept the request and we say okay. One of the things that I think is going to be helpful for you is to not have that username, because if you come in here, sometimes you can just put in your single quote and then we can put in the 1 = 1. You can type it out just like this and you can hit send, but we're going to go ahead and send this over to repeater because I want to show you that you can actually solve this lab this way. You could send this and it's going to say 1 = 1, and it's just going to log you in as the first user in the database, which is going to be the administrator. And I forgot to put the -- so we'll put that in there, and it's going to tell us not found. But if we go back over to the main page, it's going to follow the redirect and it's going to log us in, and it's going to tell us congratulations, you have solved the lab. But the way we're supposed to go about doing this is typing in an actual username. So there is going to be times when you need to just type in like admin -- okay, actually we don't need the admin right here. We actually need this over here, and it is administrator, which I have copy pasted to my clipboard, which looks like this. And then you can just have this quotation with a -- and the reason this is going to work is because this is the true person or the true user that we're really trying to log into. And then we put the single quote here to close off the entire statement, and then we put in the -- in order to comment everything out of it. Since this user is true and we're commenting out everything after it, this password doesn't matter. We can have anything in here because it's just being commented out, and the user that we're trying to log into is true. And because this specific CTF told us we need to log in as administrator, that means that if the user that we have is real, then we're going to be able to log in. So we should be able to just hit send, and it should tell us that I already used this session, so we actually need to grab a new request over here. You can actually see this work. See, our token's different, so we should be able to send this over to repeater. And now if we paste in administrator, put in our single quote and our -- to comment everything out after it, we should be able to send this, and it's going to tell us that we are able to log in. We can follow the redirect, follow, and okay, we are now logged in. So we can come over, turn the interceptor off. And if we wanted to actually get this to say problem solved, we would do all of the same things, only this time we would not send it to repeater if we want this to say lab solved. So we could intercept this, turn on proxy, get that out of here, come back over here, paste in administrator, quote -- and forward, turn interceptor off. And it tells us we are now the administrator and we have been logged in. So that is a couple different ways to bypass the login function. Now let's continue on. Okay, so we're gonna go ahead and open up this lab right here. And once this is open, you can go ahead and access the lab and we'll let that load. We're gonna pull down the number of columns that are returned from the query. So what we're essentially trying to do is get a true statement back from the server or the database saying that there are this amount of columns. So we're going to see if we can find the number of columns. And remember, we're going to get an error unless the statement is true. So once we hit the right number of columns, it's going to send back to us a 200 OK, meaning that is the amount of columns in the database. So that's where we're headed with this specific lab. And I actually think we're going to need to intercept, and I think the SQL injection is going to be right here. So let's send this to repeater and check to make sure. Put in our single quote and send it. We get our internal server error. So this is going to be where the SQL injection exists. But before we check this out, I think it would be helpful to remind you what a SQL statement looks like. And so we'll just gedit a random file. And so you're going to need to remember, this is how the statements look. It's going to be something like select all, which the star is all from users, and this will be all caps, where username equals, and then we would have, if we were actually writing this, you can go back to that first video in this SQL injection section of the course, and you can go back and check this out. It's going to show you, like, there would be something that looks something like this, and we would have the username, which would be a variable that was passed in over from the client side through the API to the server and now to the database. And we're just going to inject right here, and we would just type in a single quote, and this was going to break the statement, and then we're going to write our own query right here, and then we're going to comment out everything after it. So that's kind of what the statement is going to look like. This should look familiar to you by now because I've shown you this before. So we can just close out of that. We can close without saving, and we can come back here and we can actually write our union statement in order to get this to work. Now, when I do this, I usually write my union statements in all lowercase because I don't understand why SQL programmers, everything is in caps lock. So I just like to use lowercase because it's easier and it's too much work to hit caps lock and then start typing. So I just write it in lowercase. So we're going to go union, and then we're going to type in select, and then we're going to type in right here a row. So you can actually put in like null. You'll see sometimes people put in like 1, 2, 3 for the numbers of rows. Either one should be fine. So we'll just type in null, and this is going to test for is there one column in the database. So we should be able to highlight all of this, Control U to URL encode it, and send it, and we're going to get back an error. So then in here you just type in comma null, and you can send it. We get an error, comma null, send it, and we get back a 200 OK. This means there are 3 columns in this database. So if we come over here and we just let this proxy go, it's probably going to tell us that we solved the challenge because we were able to find the number of columns in the table, which is going to be 3. So let's just try this real quick to make sure this works. So we can go comma 1, comma 2, comma 3, and we should be able to send this, and we get an internal server error. So it is expecting a null or some kind of string right here. So it does not like integers being sent in. So it does want to see null. So in the future, we are going to be checking to see if we can pass in strings in here to see if we're able to pull down information. And so what I mean by passing in a string, if the database is going to let us make a statement or ask for information back, it'll let us put it in quotes, and we should be able to send it, and it'll give us a 200 OK, meaning we can insert into this column. So this is getting into a little bit too much depth for us at this point. So we'll go ahead and check out the next challenge and continue progressing forward. All right, we are going to be trying to solve this 4th lab right here. So it says we are going to find a column containing text, which I kind of showed you a little bit of how to do this in the last video. So we'll go ahead and open up the lab, and we already know where the SQL injection is. If you want, you can go ahead and try and see if you can find how many columns are, just like we did in the last video, and then see if you can figure out how to insert a string in order to get back text. So what we're going to do is send this to repeater. We can go ahead and shut that off actually. We'll send this, and if we read our output over here, it tells us we have a hint. We need to make the database retrieve a string, and it wants us to send this very specific string right here in order to solve the lab, and we'll go ahead and copy this. So now that we have it, we can put in our single quote, make sure we get that internal server error just like this. And now we need to find the number of columns just like we did previously. So we can just type in union select, and then we're going to need to type in our nulls. So we can say null, and then we'll put dash dash. And I'm just going to go ahead and put in a second one because we pretty much always know there's going to be at least 2 columns. And you know what I forgot to do is URL encode that. So let me type this back out. And now we can highlight, Control U, and send this. We still get an error. So let's see if there's 3 like there was last time, and we get this 200. Okay, but we still need to submit this string right here. And what you can do with this is you can just put it in each one of these nulls, send it. It says internal server error, so that is not where that's going. So we can put it in this one right here, send it, 200. Okay, and congratulations, you have solved the lab. But what I would do is I would keep checking this because we're going to need to pull down a username and a password, which means we're going to need to inject into at least 2 columns. It's going to tell us, okay, so this line right here would be able to accept an input from us. So it says we have solved this one, and now we're going to keep going, and it's going to keep building on top of this. But if you would like, you can come back over here and open up the 5th lab. Which one are we on? 1, 2, 3, 4, 5. Right here, and we're going to do all of that same stuff in trying to receive data. And you can go ahead and try and get this far and see if you can figure out which columns allow you to have input, and then we will pick up from there and solve whatever challenge it has next for us. All right, here we are. We are going to be doing this lab right here. We're going to be retrieving multiple values from a single column. So we're just building on top of the previous lab where I showed you that we're only able to inject into one of the 3 columns. This is usually pretty uncommon. Usually you'll be able to inject into more columns, but in this case, it wants us to only inject into 1 column. However, I believe we need to pull down the usernames and passwords, which means we're trying to get data from 2 columns, but we need to get it from 1 column. It sounds really hard, but it's actually extremely simple, especially once you know that we're just using a simple SQL database. And even if you didn't know what database we were using, such as like Oracle, it's still pretty easy to figure out just by doing some guesswork. So I've gone ahead and opened up the lab, and you can open it up too, and you'll be brought to a page that looks like this. And we're going to be trying to do a SQL injection in the same place we have been doing. So you can click any one of these tabs because that's where the SQL injection is going to be. We will send this over to repeater, and we can send it, make sure it all works. Looks great, and we'll check to make sure this is where our SQL injection is at. Send it, and we get our internal server error, which is good for us. So we can type out our payload like we previously have, and I'm going to go ahead and skip it this time, and then I'll bring you back once I have it all typed out. Okay, I have it all typed out, and I actually put in 3 nulls, and this time we find out there's only 2 columns, and I accidentally messed those up. So we have 2 columns this time, and we need to see which one allows us to insert a string. So if we put some quotes around that, we still have our internal server error. So we'll take those quotes off and put them around this null over here and see if that's where we are supposed to insert our payload, and it is, so we get this 200. Okay, now at this point you're probably thinking, how do I pull down the usernames and the passwords? I want to show you a little trick that if you're ever stuck and you know what you need to do, but you can't figure out how you need to do it, some SQL injection payloads can be insanely complicated and they can look like a mumbo-jumboed mess. And one of the simplest things you can do, if you know you need to run a SQL injection but you don't know what you need but you don't know exactly the right syntax, you can just highlight this right here and we can copy it. We need multiple values from a single column because we're able to have two columns, but we need multiple values, meaning the username and the passwords, which right here, we need the username and the passwords from a single column. So what we can do is go to our great friend, the Google machine, and we can hit enter. And we're going to need to turn our proxy off if we actually want to get any information back from our requests. And we are going to just click on this first one right here. You could even come down here. Stack Overflow is a great place to go if you're a programmer you're best friends with. Stack Overflow. So we can just scroll through here and it's going to tell us in Oracle, this little pipe quote dash pipe is going to be like an and for us. So it's going to say we want username and a password. So whether we're using Oracle or Microsoft or PostgreSQL or MySQL, it tells us what we're going to kind of need to do here. So we'll just go ahead and try the Oracle one first. If that doesn't work, we'll just work down the line. So what we can do is come back over here. I'm actually going to pull these apart so I can see exactly what this looks like because we're not allowed to copy that. So we can come back over to repeater and we're just going to type in simply username, add in two pipes, and then our quote dash quote, and then our two pipes again. And we also want the passwords, and we want to grab this information from the users table. And I believe we're told that we want this from the users table right here. So we're going from, and then we're gonna put in the users table. So that is where I get the users table from right here, from users. So what we can do is highlight all of this. We can URL encode it. We can hope for the best and that we don't have any typos, and we can send it. And we get a server error, so that means we have a typo or something went wrong for us. Let's actually try and delete these plus signs because I don't think we need these right here. Let's try and send this. Do we need a space in here? We do not. And I see my typo. We have passwords right here, and I'm pretty sure that it told us we want just a password. So let's send this, and we get back an okay. Is there any information actually in here for us? And there is. See, we have a user and we have a password. We have a user and we have a password. So that is how you'd pull back a username and password, or you're trying to get multiple values from a single column in the world of SQL injection. So you just kind of know that if you can only inject into one place, then you're going to need to Google how do you solve the problem that faces you, which is what I really wanted to show you in this specific lab, because if you come down here and you actually click the solution, you can see that you have like this squiggly line right here, but in the payload we used, you just have a simple dash. You can have multiple ways to do something. So even if we come back over here and let's say we check out this one right here from Stack Overflow, I bet that it is going to tell us what we need to do. So you have the full statements here in the Stack Overflow. And let's see, there's some videos that'll tell us. I bet those are walkthroughs for this lab. We can come to the write-up, and I bet this is also for the lab. And it's going to have something in here for us. Let's see if they use a different payload. They do not. They use the same payload as what was given in the solution. Anyway, one of the best things you can do is if you know what you need to do and you don't know how to do it, is just Google the answer. So with that, we are going to move on into the lab right here. I forget which number we're on. It looks like this is number 7. So we're going to be working with Oracle, and I'm pretty sure this is going to be pretty easy as well, especially if we just Google what we're supposed to do. So let's go ahead and open this up and get started with it. All right, we're gonna go ahead and do this SQL injection, finding the version for Oracle, and then we're gonna check out this one right here for my SQL with Microsoft, just because I want you to see the difference in how you craft the payloads, and then we might do a blind SQL injection or two, just because I regularly get questions on blind SQL injection. And then we're gonna go check out SQLmap and do some try hack me or hack the box and how to find SQL injection with SQLmap. So that is where we are headed. You can go ahead and open up this lab right here. I have already opened it up. You can click Access Lab and you're going to be brought to a page that looks like this. Now we're going to do the same things we have been doing. We're going to intercept the request. Click on one of these things, buttons over here to refine our search, and send to repeater. We can shut this off, repeater, send, make sure everything is working, put in our single quote and send it. Now we get the internal server error, but before we start crafting our payload, I think there is something you need to know. In Oracle, it is going to be a little different to craft our payload. We're still going to be doing a union select statement. But with Oracle, we need to pass in strings right here. So you can just pass in to strings. It doesn't really matter what you put inside of the strings. You just need to be able to see if we can get back a true statement. But with Oracle, we need to select the table we're going to be pulling from. And so we would say from dual. And if you are curious, you can just copy this right here or type it in. We can go over to Google and we can just type in dual Oracle database and we can just hit enter so you can see what this is. And actually we'll just type in what is dual Oracle database and it'll tell you. Dual is a table automatically created by an Oracle database. So when we type in this dual that you see right here, we need a table that actually exists in order to get our true statement back. So that's why we put this from dual in here, and we hadn't been doing that previously. So we can go ahead and click Control U, URL encode it and send it and see if we get back a 200. We don't, which means we have a typo, and I see that we don't have our dash dash, and we send this and we get back our 200 OK right here. So now we're trying to get back the version of the Oracle database. This is pretty simple. All you need to do is come back over here to Google and type in getting version SQL injection Oracle, and we'll see what comes back. Pentest Monkey is really great, so we can click Pentest Monkey and we see version right here, right at the top, and we just need to type in from this version right here like this. So we can actually just copy that so we don't have to type out that $version. We can come back over here, and because we have these 3 columns, we can delete 2 of them. And we can paste that in right there. So we have a column right here. We're gonna have this plus show up right there. We can URL encode it and send it and hope for the best. We get an internal server error, which means we have a typo. And if we come back over to our payloads, we need to have from select this banner right here. So we can actually go union select banner, and then we're gonna have our null from the version over here. So we'll need to come back over to crafting our payload, and we can just type in a plus and we can just type in banner. So now we have this union select banner, our empty column from version right here. We don't really need that plus right there, and then we comment out everything after it, and that should work for us. And it does not, because we have to have a comma right there. Okay, so my typos ended up being there needed to be a comma right here, and we had to delete the comma after our string right here. So now we get this 200 OK. Let's see if we go back to the lab, it tells us we have solved the lab. So that is how you can kind of go about crafting your own payload in order to pull down the version. And I'm not entirely sure this is how the proper way to do it, if this is what Port Swigger was looking for, but this is how I would go about crafting my own payloads. So you can see ours looks a little different than this, but there are many ways to solve a lot of hacking challenges or problems that you're going to face in the future. And so this is kind of how I do it. I would just Google around and craft my payload based off of the responses that I am getting inside of Burp. So with that, let's go ahead and check out the MySQL. So you can go ahead and open this up. We can access the lab just like this, and we're going to go about doing this the same way we did the other one, but you're going to be able to see that our payload is going to be a little different than what we have over here. So we can come back over to proxy, accessories, send to repeater. This should be really familiar to everybody by now. We can shut that off, put in our single quote, make sure this is where the SQL injection is, and we get our internal server error, which means this is where it's at. So now we can just go union select just like we would have previously. And if you didn't know that this was Microsoft, you can actually just type in how to craft a Microsoft payload for SQL injection and read through Google, and you'll be able to figure it out. So we should be able to go null dash dash. I'm actually not sure how many columns we have, and I do this every time. I forgot to URL encode it, so select, not selection, null comma null dash dash, URL encode it, and we're gonna need another plus right there. Send it, we get an internal server error. Let's try, are there 3 columns or is our payload wrong? Looks like we need to modify our payload, and I actually believe Microsoft requires a hash like this at the end as a comment. So let's delete these now and send this, and we get a 200 OK, which means we need a hash inside of Microsoft SQL in order to comment out everything after our statement. So now we have these nulls, but one thing I wanted to show you inside of Microsoft as well is you should be able to pass in these integers where we couldn't previously pass these in. We had to have in null, and I think most MySQL databases will allow you to pass in integers. So we are able to pass these in right here. I don't believe we're able to use integers inside of Oracle, so you can kind of use that a little bit to try and figure out what is running on the back end of a server in the database. So we have this right here. Now to find the MySQL version, you can just copy this like we did before, because we need to know what payload we need, but we might be able to find it in here. It doesn't look like it's going to show. So let's just see if MySQL will work for us. So we're going to do a select at version. So we can just copy that, come back over here, and we'll just put it in this first section. I don't believe we need any quotations or anything. So we'll send this and see if this works for us. Does not say that it is solved. We have a server error. Let's check and type this over to null. I see I copied too much of it. So you guys probably caught that in the video. We don't need 2 selects. Let's send this, and we get a 200, and it says we have solved the lab, which means in our response, it's going to tell us what the server or the database is running on the backend. So this is how you would go about doing a Microsoft SQL injection. Now let's go check out a blind SQL injection and then move on to some SQLmap and enumerating on a CTF on Hack the Box, and then maybe we'll do some with Try Hack Me as well. All right, so we are going to be looking at this lab right here, and I decided to go with this blind SQL injection lab right here because it is pretty simple to solve. And some of these other ones require you to craft a payload, and blind SQL injection can be really hard, and I'm going to show you why. So go ahead and open up this lab right here. You can open it up. It's going to tell us that the application uses a tracking cookie for analytics. So we're going to guess that this time our SQL injection is going to be in the tracking cookie, and if they hadn't told us this, this lab would be very hard. So I'm going to show you why this is. If you come over to the lab and you open up your proxy and we intercept the request and we click on one of these like we normally would and we send it to repeater, we turn our requests off and we're over here in repeater. what you can do is if you put in a single quote all over the place and you send this, you're going to get back a 200 OK, which means we're missing our internal server error, which means we have no help in crafting our payload. So if we delete these little single quotes and send this payload again, we're going to get the same thing. Now, if I was on a live program, I'm going to show you that I would end up wasting a ton of time with this. If I was on a live program and I was just putting in single quotes and I put one in right here at the end of this category where it has been, you can see down here our bytes are 3,443, and no matter how many times I send this, it stays the same. But if I delete my single quote and send this, we get back 4,999. And if I was out in the wild doing this, I would be wasting my time trying to figure out what is different over here in the response, trying to find the error or trying to figure out how to exploit something right here, because there is a difference. Our little single quote does something, but that is actually not where the SQL injection is. So we have this 4,999 bytes. And if we come over to this tracking ID, which is where we're told the SQL injection is from over here, we have this tracking cookie. If we go ahead and put this single quote in and send it, it comes back with the same amount of bytes. So in the real world, I would just assume that this is not vulnerable and I wouldn't want to waste my time with it. So this is why blind SQL injection is so hard to find. But we know this is where it is, and we don't know what version it's running. So what we would do is we would come back out to Google, and we would come and we could just start at Oracle, and you can just hit Command Find, and we're looking for a time delay, and you could just start copying these and pasting them in over here until you get something to a time delay. This would be a massive waste of time if you were in the real world and you were trying to find a blind SQL injection. There are a lot better things to look for rather than just waste your time doing something like this. But because we are supposed to be solving this challenge, I believe this one is PostgreSQL. So we can hit Command Find, take us down to the time delay. We're going to be using a select statement, which means we're going to be using union select, and then we're going to run this PG sleep 10 right here. So we can copy this, come back over to our tracking ID. We're going to use a double pipe, and the double pipe in PostgreSQL, and I believe also in Oracle, is just a concatenation onto the previous statement that is going to be made from the server to the database. And if none of that makes sense, you can go back to the beginning of this where we actually write the code for a database and you get to see how the server works. It's just concatenating onto the server code and sending that to the database. So we can paste this in and then comment out everything after it. And this should sleep for us 10 seconds. And it is going to work for us. And then I'll bring you back once that works. And so we should be able to come over here and it tells us, congratulations, the lab is solved. So that's how you'd go about finding a blind SQL injection. It takes a ton of time if you're going to do this in the wild. They're really difficult, especially if you have no context and it doesn't tell you like it's in the tracking cookie. You could spend a lot of time, like I would have, searching up here for an SQL injection, because our single quote actually causes our server to send back a different amount of bytes to us. So that is blind SQL injection. Now let's go ahead and check out SQLmap. Okay, so here we are on the box writer. I've gone ahead and typed in administrative right here rather than having you watch me fuzz for this. So at the beginning, this is going to look pretty simple, just like we normally look for SQL injection. We can just put in some random characters, and then we can turn our intercept on and we can sign in. So this should look pretty familiar to you. Let's go ahead and send this to repeater. If we come over here and we put our single quote in these different places and send these, it doesn't appear that there is any SQL injection. Those are not single quotes. So that would probably be why you guys are thinking I've lost my mind. We still have no internal server error, which means if there is SQL injection, it's going to be a blind SQL injection. Now, just to be straightforward, you can type pretty much anything right here and then just do a dash dash and then space dash, and this is going to comment everything out after this. And if we send this, it will actually allow us to log in to the admin panel, I believe. Let's go ahead and try this just to make sure that this works. We can shut this off, come over here, paste something in, and it does not work for us. So I bet if we do that same payload with admin in here, we already have seen something like this where I said you need to do the administrator earlier in a different lab. and it says welcome and we're in. So you could fuzz for a specific user right here inside of Burp. If we grabbed this in here and we just forward all that and we sign in, we could send this over to intruder and you could fuzz for the user right over here and you were able to get this to work, or you could just use something like SQLmap. So what you can do is come in here and we can copy, where is it? Copy to file right here, and then we'll just save it into this SQL, this old file that I have, and we can save this. Yes, we're gonna go ahead and save it. And actually what we need to do is save this. We'll just save this like this, so that way you can actually see it completely run. So we can come in here, copy to file, overwrite this, again, save this to a file. Now I've already ran SQLmap so that you don't have to wait for it to run, and we can actually take a look at how this SQL statement is going to work for us if we weren't able to bypass the login and we actually needed to pull down users or usernames in order to solve this specific CTF. We could come over here to our SQLmap. We can scroll up and you can see the statement. This is just SQLmap. It's going to automatically be installed on your Kali Linux machine. The request is going to be made to the file that we saved this into. So if we just cat out SQL like this, you can actually see the post request right here that we saved. So if we come up to the top, the -r is the request, the --batch means that it's just going to automatically answer all of the questions for us. So if we scroll down and look at this, it tells us that we have a database, which is MySQL, and then it says here is the payload that it was able to use in order to see if this was actually injectable. So we can go ahead and copy this payload, and we can come back over here to our request in repeater, and just to show you, if we send this, it's going to tell us that we are not logged in. It's got incorrect credentials, and if we just copy this and we paste this and send this specific statement, I don't think we need to URL encode it. It should sleep for 5 seconds, and it'll pop up down here in this little corner that we waited for 5,000 milliseconds, which is going to be 5 seconds. And you're going to be able to see, okay, this is, as the SQLmap says, this is a blind, right here, time-based blind SQL injection. Now, when you look at this SQL statement, this would be really hard to figure out, like how many closing parentheses do we need and where these little quotes need to be, and SQLmap does all this for us, and it's really simple and saves a ton of time. So this is why SQLmap is such a handy tool, and you're going to want to know how to run it. So when you run SQLmap and you need to see if there's just an SQL injection, this is probably right here the best way to run this and just see if it's injectable. Then if it is, I'm glad this is done running, we can run a --batch with the DBS. You can see I accidentally ran it up here with a DB, but you're going to want it run it with the DBS, and this is going to pull down all of the databases for us, and it's going to spit it out nicely for us. So here's the payload it's using, and if we come down, it should tell us where the databases are. We have information schema, which is going to be default. You're going to see this on almost every database that you try SQL injection on. And then we're going to have this writer right here, which is going to be the database that we want to attack. I actually have not ran it over here, so you're going to be able to see what this looks like. We can just paste that in right there. So we're going to run this --batch with a -d, and this is going to be the database writer, and we want the tables, and I think this is a -- tables. It's going to tell us if we're wrong, and it looks like I must be wrong, and I accidentally put in an extra one instead of deleting. So delete, and run. I'm in the wrong directory. That's the problem. CD over to desktop, and now we should be able to run this, and it's going to pull down all of the databases for us. So this will actually take a little while to run, and then it's going to be pretty simple. Once we get that, we're going to move over here, and we're going to run the tables, which we actually have right here. We have the database, and then we're going to pull down the table, which I'm going to guess is going to be something like passwords and usernames, because that is typically what we want to target when we're doing some kind of SQL injection. So you can actually see right here, it's running the time delay, and it's going to try to retrieve all of the tables for us, and then we'll be able to pull down, I don't actually know what's in here, the usernames and passwords, hopefully. And then I guess while this runs, there is one more injection payload that we are going to want to run. So we can copy this. And once we know what we're going to be using for a table, like let's just say there was a users table, we would run something like this, and we're going to type a dash dump, and this will dump all of the users inside of the users table. And then you might have to delete this and come back and say, okay, now we want to dump all of the passwords within this table that is found inside of this database. So that is how SQLmap works. This is going to be really important for you to know. You're going to want to know it, and you're going to want to use it. So we do have a users right here. So we could just come back over here, and we would say we're going to dump from the users table. Make sure it was users and not user. It is users. And then we would just let this run, and it's going to spit out everything that's inside of the users database, inside of the users table for us. So it says fetching columns for tables, the table users in the database writer. And so you can see just how easy this is for us when we have a very tricky payload that looks like this right here to pull down the information. And you can see it's actually retrieving. It's going to have the IDs. It's telling us it's making good time. And hopefully it looks like we're going to have IDs. We're probably going to have a user, and we're probably going to have a password. So I'm going to go ahead and let this run, and then I'll bring back once it is finished, and maybe we can log in as one of the users that we pull back. Okay, so rather than have you guys watch this run, this is how SQL injection works. And in the real world of a CTF, you would be able to take the ID, the username, and the password, and then you could come over here and you could log in as any of the users that you're able to pull back from this database. So thanks for watching, and let me know if you have any questions in the comments below. In this video, we're going to talk about how to pull down passwords from a SQL database, as well as authentication bypass. We're going to be using TryHackMe, and you can actually access JuiceShop for free on TryHackMe. That's what I'm going to be using. It is going to be a little bit buggy, but I'll show you how to get around that if you want to follow along. And it is completely free. You just have to make a TryHackMe account and then type in JuiceShop, and you'll be brought to a page that looks similar to this. You will have to download your VPN authentication, which you can do by just scrolling up here, clicking access room, and then download, and then connect through the VPN, and then go ahead and start your machine. I already have mine running and have pulled open OWASP JuiceShop. So the first thing I think we'll do is we'll just talk about bypassing the authentication, because it is probably the most simple. And then I'm going to show you how I found the SQL injection to actually pull down the database through this little search function by the login bypass authentication. So we'll go ahead, click account, and you can click login, and you're going to be brought to a basic login page. So we will want to turn our interceptor on. We'll type just anything in here. We need to come back over here. We'll hit login, and then we can come back over to burp. We'll forward this, and then we're brought to this little post request right here. And so we're going to send this over to repeater, and you can go ahead and send it, and it's going to tell you that it doesn't log in for you once it decides to load, and it tells us invalid email or password. And just for the sake of bypassing this authentication, making it actually look nice, this is being sent through as JSON right here, and that's why we have this right here. But we're actually going to send this through as x www-form, and I think it is URL encoded. Let's just copy this right here, and we'll paste that in, and it should tell us URL encoded. Yep, just like that. So URL encoded. And then in order to make this work, we will delete equals, and delete these. And I'm just doing this so that you can see it will look a lot better, and it's actually easier to try and bypass or send data back and forth to the server and get responses if you use the URL encoded. It's just, I like it better. It's a lot easier in my opinion. So this is how you would go about setting that up. Now, if we send this, we should get invalid over here, and it works for us. So we are now using this post request, and we're using the URL encoded. Much easier than using the JSON down here, I think. So what we can do at this point is, if you come back over here and you put in your single quote and you send this, we're going to get an error. So we get this little error right here, object. So if we come back to burp and we send our single quote, we're going to actually get to see what this looks like. Okay, so we get our error back. That actually took me quite a while to get this error, like at least 15 seconds. So we get this SQLi error right here, and you can just copy this, and we're going to need to use this a little bit later. So we can see the SQL statement, select all from users where email equals this and the password equals this over here. What we're able to do with this is actually take this statement. We're going to remember this SQLi error right here for later. But we have select all from users where the email equals whatever email right here, and password, which is what we just typed in right here. And this is MD5. So if you go and copy this and you take it to Hashcat or some kind of decryptor on the web, it'll actually tell you whatever password we typed in, which is right here. So what we can do, seeing this statement makes this really simple. What we can do is we can just comment out all of this after our statement. So you can come over here and you can just type in, leave our single quote. We could type in or 1 equals 1, and then we'd run our dash dash, and we actually need a plus right here for our space to make this URL encoded. And now if we send this, we're going to get an authentication that we are logged in right here as the admin. If we come back here, it just asks for the email and then that's it. So what you can actually do with this SQL injection is come back to the main page and just look for a user right here, like this Bender at Juice Shop, and we could copy this and we can actually just paste this in right here and then run the dash dash and bypass the login this way, and we're going to be able to log in. Okay, and this is what I get for not actually testing these out before I record the video. So what actually works here, now that I am thinking about it, is we can delete this, and we need our single quote over here, so that way we're closing off the statement and commenting everything out. So if we look at it over here, we're going to get rid of all of this. So we're going to put in the proper email, and then we need to close off our statement over here so that way it works and we can comment out everything after it. So now if we send this, we get logged in right here as this user. So we should be able to come back over here and paste this in. We got our single quote, and if we log in, it should work for us, and now we are this user over here. So that's some authentication bypass right here, but now we're actually gonna try and pull down some users. We'll pull down all the users and all the passwords for everybody who's ever used this website right here. So let's go ahead and check this out. The way you would go about this if you installed Juice Shop locally on your machine is to come up to the search bar, and you can just type in like banana, and we would catch this in our proxy. Here, we'd come back over here and we would just hit enter, and we would forward. I accidentally forwarded too far. So we'll just go ahead and turn that off and turn this back on and put in an S, and we got this right here. So we have this verified local XSS challenge. Now the reason this is not actually pulling down the page that we need is because it's trying to see if we're completing the XSS challenge, which obviously we're not. So we can forward all of this, and we're not actually ever going to see our GET request that we are trying to make to the server. So we can just hit continue all day long. But what we are able to do is come back to our login page, or our login that we was looking at over here, and we see we have this REST right here. This means we're running a REST API, and we have the users, and then we have the login. So what we can do is come back over to this page, and what we can do is come to the front here, and we can just type in REST, and then you will see that we are using the products right here. So if we type in REST, and then we type in products like this, and you can also find this by fuzzing the page, and then we can now intercept this and see what it pulls back for us. Because we see this REST right here, we're actually going to get JSON in response, which is going to be really nice for us. So if we send this to our repeater, shut that off, actually we might even get an error message over here. So if we come back over here and we send this, we get this internal server error, which means we're causing a problem. And we should be able to add a slash in there, and now we get a success just like this. So now we know that this is an endpoint right here, and we can put in our single quote at the end of bananas, and we're going to cause that internal server error right here. And if we actually come back to the web page over here and we type this out the right way, and we hit this / and hit enter, we are brought back to this JSON response right here. So we can actually, let's see if we delete this and hit enter, we get back a full list of all of the products in the server. So if we look at this, we can count these and we can go 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we know there are going to be 9 columns within the database that we are pulling back from. So because we know there are 9 columns, we can just leave this. This doesn't really matter because we're going to be injecting right here, and we're going to be using a union select, just like this, a union select, and then we're going to put in our columns right here. But because we know there are 9 columns, what we can actually do is just start out with our 9 columns. If you, in the wild, you're probably not going to get something back here that's going to tell you there are 9 columns that you need to inject into. But because we're able to count these, we know that there are 9 columns. So what I'm going to do is I'm just going to fast forward me going ahead and typing out 9 columns. Okay, that should be 9 right there. And what we can do at this point is we're going to say from, and we actually should be able to send this and cause an error. We get a bad request. But if we come back over here, we have this SQLi error that I told you was going to be important. We can copy this, come back to Google, paste it in, and see what we are brought to. So let's go ahead and click this schema table, and that actually tells us what we have right here. There are 3 table names, and we're just going to go with the first default table name, and then we'll come back to burp, and we can say from, and we want that SQL master right here, this schema. So now what we are going to do is actually we'll add our -- and then we'll highlight all of this and hit Control U for URL encoding. That looks all right, and if everything was done right, this would actually tell us that we don't have an internal error. So I have a typo somewhere. I'm going to look for it, and then I'll let you know where it was. So the problem actually now is that I'm looking at this is going to be right here. We have to close off the SQL statement that comes before what we're trying to inject into. So we should be able to add these 2 parentheses and see if this works. Cross our fingers, and it does. And we have back all 9 columns. And we should be able to, at this point, come back up here, and we're going to look at the SQL right here. So we're going to look at the SQL tables, and we're going to be able to tell that, let's see, there is a table name with, let's see if we can find, there's users right here. The table name users is now the one that we want to look at. So instead of using the SQL, what was it, the SQLite master, we're going to use the users. So we could use users and come back up here, and from the user table, we want the email and the password. So we should be able to send this, and it should work for us. And now we get the ID and the name, and we're going to be able to get, this is the MD5 password right here for all of the accounts. All right, and that brings us to the end of our SQL injection crash course. If you have any short courses that you would like me to make in the future, please let me know down in the comments below, and let me know if there are any questions you have specifically over SQL injection, and I can try to answer those either down in the comments or make a separate video for those. Thanks for watching.